Question 10. If a equals 0.99, which of the following is or are less than a? All right, so here we're entering the upside down, as in Stranger Things, because when 0 is less than a is less than 1, we enter the upside down where the normal rules don't apply. For example, the square root of a is 1/2 when a equals 1/4. Normally that's not the case. If you have the square root of 4, it's equal to 2. So the square root is larger when you're dealing with a fraction that's between 0 and 1. So it's positive, but it's smaller than 1. So the same applies to a even if we don't have a calculator. So a is 0.99, that's just barely, it's 1% less than 1. And so the square root of a is approximately 0.995. That's really easy if you have a calculator. You just go, okay, 0.99, what's the square root? Yeah, 0.99498, so just 0.995. Anyway, you just have to know that if it's less than 1, it's going to be larger. So cannot be cannot be 1, rather. Okay, 2a squared, well, okay, we go 0.99 times 0.99. We get 0.9801. So 2 is less than a. And then, all right. So the next thing we do is 3. 1 over a, well, okay, that's 1 over 99 over 100, so, 0.9. So if you did it without a calculator, you could just go, well, that's 100 over 99. You don't have to be a math genius to know that 100 over 99 is a little bit bigger than 1 because the numerator is bigger than the denominator. But if you do, you can just go 0.99, and then you can just go 1 over that. So it's 1.01010101011. So it's not less than a. It's just slightly more than a, because it's greater than 1, so it's greater than a. So the answer is C, that's 2 only. Okay, question 11, page 468. All right, for the final step in a calculation, Paul accidentally no, he didn't. All right, talk about miscalculations. Anyway, for the final step in a calculation, Paul accidentally divided 1,000 instead of multiplying by 1,000. What should he do? Well, let's call the number before that misstep C. So he got to C. Paul wanted C times 1,000, but he divided, so he got C over 1,000. So the first thing we're going to have to do is multiply C times 1,000. We're going to apply C over 1,000 times 1,000. So we just take C over 1,000, which you have here, multiply it by 1,000 to get C back. So now we're going to multiply C times 1,000 to get our final answer. Since we multiplied by 1,000 twice, we multiplied by 1,000 times 1,000, which is equal to 1,000,000, or 1,000,000. If you don't believe me, fine, I'll get the calculator out. So here's 1,000 times 1,000. Okay, that's 1,000,000. So another way you could do it if you like to work with exponents is, 1,000 is 10 to the 3 times 1,000, okay, then which is also 10 to the 3, and you just go 10 to the 3 times 10 to the 3, which is going to be 10 to the 3 plus 3, which is 10 to the 6, which is 1,000,000. And another neat thing to do here is you can just go, well, all right, we know that 10 is 10 with 1 with 1 0 after it. So 1,000 is 1 with 3 zeros after it. And 1,000,000 is going to be 1 with 6 zeros after it. So you can see where they put these commas. Okay, this is 100,000s, this is 1,000,000. So you can just go 10 to the 6, go, okay, I write 0 6 times before I write the 1. 1, 2, 3, 4, 5, 6. Boom, that's 1,000,000. All right, irredeemable miscalculation. This is a bridge, I think it was in Washington State or whatever. It basically blew down, very shortly after it was built because unfortunately the wind got it to shake at just exactly the right, whatever vibration, harmonic point, the natural oscillation that would cause it to fall apart. So this is that one where you can see the old-fashioned cars on it and the thing's shaking apart. So what you thought was your greatest achievement completely annihilates your career in a matter of minutes. So make sure you get your calculations right when you're working on things. Question 12, page 468. One day at Central High School, 1/12 of the students were absent and 1/5 of those present were on a field trip. So if the number of students staying in school, that is, they were marked present and on the school campus, was 704, how many students are enrolled at Central High? So let's set up the equation here. So let's have E equal to the number of enrolled students at Central. So if 1/12 were absent, 11 over 12 were present. So 11/12 over E were present. So since 1/5 went on a field trip, 4/5 stayed in school. So 4/5 times 11 over 12 equal E stayed. We quickly see that 4/12 is equal to 1 over 3, because you have a 4 on the top and a 12 on the bottom. So we have 1/3, and then there's 11 and the 5 that are on the top and the bottom. So 1/3 times 11/5 E equals 704. 11 over 15 times E is 704, and 15 elevenths times 704 equals E. So hopefully this is on the calculator section, so you can just plug in the numbers with the calculator and get something like this. You get 15 over 11, and you're going to multiply that times 704, and voila, you get 960, and you're done. Okay, but let's say they just do something really fiendish. It's your unlucky day, and this is on the no calculator section. What do we do? Well, we could eliminate answers. Oh, wait a minute, this is a grid question in the book, so what do we do now? Well, we know that 15 over 11 times 704 equals E. This is a contrived SAT problem, so it's not really that hard if you know the tricks. And one thing they do try to do on the SAT is they try to mirror reality to some extent. So high schools don't have partial students. That is, the answer is not going to be that it has 938.625 students. Students are whole numbers. And yes, I know that's South Park where they have the guy who doesn't have any legs and they call him Halfy. He still counts as a whole person, okay? That's mean. Why'd you say that? Alright, I'm kidding. Anyway, question 12. Page 468 continued. So that means 704 must be divisible by 11 since 15 isn't, and the result has to be a whole number. Alright, well remember 11 times any digit is just that digit twice. So it's going to be 5 times 11 equals 55. So let's see. 60 times 11 is equal to 660, because 60 times 10 is 600, 60 times 1 is 60. So we're getting close. Well, alright. The only multiple of 11 that ends in 4 is 44, so hey, why don't we try that? 11 times 60 plus 44, well, that's going to be 660 plus 44. Hey, that's equal to 704. Didn't even have to use a calculator. So then we know the number is 64 because 44 over 11 is equal to 4, so it's 60 plus 4. So we know the number is 64. So the answer is 64 times 15, and then we can just use the distributive property again. 64 times 15 is the same as 64 times 10 plus 5. So 64 times 10, we have that here. That's 64 times 10 is 640. 64 times 5, well, alright, since we know that 64 times 10 is 640, and we know 5 is half of 10, well then, alright, all we have to do is take half of the 640, and that's 320. That's pretty easy. So the answer is 640 plus 320 equals 960. It's a lot of work, but you can actually do that in the time the SAT allows without really messy multiplication you probably haven't done since 5th grade if you try to write it out the way that you learned how to do multiplication by hand when you were in 3rd, 4th, 5th grade, and so on. So the distributive property is our friend. This is also a really good way to figure out a 15% tip, because it's easy to find 10% of a number. You just take 1/10 of it, and then you just add half of the 1/10, and voila, you have yourself a 15% tip. Question 13, page 468. What's a possible value of x if 3/5 is less than 1 over x is less than 7 over 9? So there are at least 2 different ways to do this. My favorite way is just to find the lowest common denominator of 5 and 9, which is 45. So 27 over 45 is less than 1 over x is less than 35 over 45. So we're just going to multiply 5 times 9 because 5 and 9 don't have any common factors. So the lowest common multiple is just 5 times 9. Alright, so 3/5, multiply that by 9. 5 times 9 is 45. 3 times 9 is 27. Alright, so 9 times 5 is 45. 7 times 5 is 35. 27 over 45, 35 over 45. So that's just going to be 1 over x has to be something in here. We know that 1 over x has to be equal to something over 45. Whenever I do this problem, I just pick 30 over 45 because it's really easy. So then one value of x would just be 45 over 30. We just flip it, and that's 3/2. That's easy to grid in, no problems. So the math teacher way to do this would be take the inverse of all the fractions, and then realize that if 3/5 is less than 1 over x is less than 7 over 9, when we're flipping it, you have to change the orders, because If 7 over 9 is greater than 3 over 5, which it is, then 9 over 7 has to be less than 5 over 3, and x is still going to be in the middle, just like 1 over x was still in the middle. So we find the lowest common denominator. That's going to be 7 and 3. Again, there's no common factors, so 7 times 3 is 21. Okay, so we have to multiply 7 times 3, then we have to multiply 9 times 3. That's 27 over 21. And then 5 over 3, okay, 3 we're going to multiply by 7, so 5 we multiply by 7. That's 35 over 21. 5 times 7 is 35, 3 times 7 is 21. So x is going to be something between 27 over 21 and 35 over 21. We can pretty quickly just use our calculator, assuming that we're allowed to use it, and just go 27 over 21, which is 1.2857, blah, blah, blah. So I would just round it up to, 1.29. And then, okay, 5/3, well, you should be able to figure that out, but in case you can't, 5 over 3 is 1.66666, so 1.67. All you need is a number in between, anything in that range. So again, I would probably just put 1.5, but you can put whatever you like. Okay, question 14. If 7a equals 3 and 3b equals 7, what's the value of a over b? Well, this one's straightforward and easy except for one twist. You want to solve both equations to get a equal to 3, 7, because you can see all you have to do to get a by itself is divide both sides by 7, so you get a equals 3 7ths. 3b equals 7, okay, we just divide both sides by 3, so b is equal to 7/3. So the twist is many students will multiply instead of divide, so you're going to think, oh, it's a contrived SAT problem. I get it, the 3 7ths and the 7/3, you just multiply them and they cancel out to 1. Oh, ha ha ha, those tricky people. Yeah, they're a little trickier than you thought even, because while that's a usual good instinct, it's not good here because you're dividing. So a over b is 3 7ths over 7/3. And of course, when you divide by 7/3, it's the same as multiplying by 3 7ths. So you get 3 7ths times 3 7ths, which is equal to 9 over 49. Grid that in and remember to check your work carefully. Question 15, page 468. If a is equal to the set containing 1, 2, and 3, and b equals 2, 3, 4, and c is the set of all fractions whose numerators are in a and whose denominators are in b, what is the product of all the numbers in c? So this one isn't really that hard, it's just tedious and detail oriented. So first you want to set up the problem carefully and methodically. So you want to go through a in order, 1, 2, 3, with each element of b under each element of a before moving on to the next element of a. So we go 1 over 2, 1 over 3, 1 over 4. So 1 over 2, 1 over 3, 1 over 4. Okay, then we start with 2. 2 over 2, 2 over 3, 2 over 4. Then we go 3 over 2, 3 over 3, 3 over 4. So first thing we're going to do is remove the 2 over 2 and the 3 over 3 before we multiply, because they're just 1, so they're not going to change the result. So, and then we just cancel out the numbers on the top and the bottom for the same reason. They just multiply 3 to 1. So we have a 2 here, okay, and a 2 there. 3 here, 3 there. Okay, 4, there aren't any 4s on the top. Okay, so here's another 2, there's another 2, those cancel out. Here's a 3, there's another 3. Boom, those cancel out. So then we have a 4, there's still no 4s on the top. Okay, well everything canceled out, all the 2s and all the 3s, so literally all we have is 1 over 4 times 1 over 4 times 1 over 4, which is equal to 1 over 64. So grid that in and be happy. So for the best results, you want to use the Barron's SAT 30th, and that includes the Premium Study Guide. Either 30th edition is fine, or the 29th, or even the 28th edition, which I believe is the Barron's new SAT. So this video, in case you haven't figured it out by now, covers pages 467 to 468 in the 30th edition of Barron's SAT, but the page numbers are the same in the 29th edition, and they're identical or close enough in the 28th and previous edition. You shouldn't use an edition older than Barron's new SAT. It'll say Barron's new SAT on the cover from 2016, or maybe it came out in late 2015. Doesn't really matter in any event. They came out with that for the current version of the SAT, which was called the new SAT a few years ago because it was new. So, not everything in the book is in these questions. Please read the book. You can get older editions of this book, like the 28th or 29th edition, cheaply, if not for free, from used booksellers, kids who've already taken the test, public libraries. They often sell or give away old editions. Literally, I've bought old SAT books for a dime at public libraries before. So, or you can borrow the current edition from the library. If you do plan to borrow a library copy or go buy a new edition, I suggest you start early. One, you really should, because you're not going to be able to learn all this in 1 or 2 nights or a week or whatever, unless you're already really, really good and all you need to do is do a very superficial review. And also, of course, there's just no worse feeling than needing a library book that someone else has checked out, or trying to buy a review book that's sold out. And, you know, even with Amazon Prime 2-day delivery, that might not be in time if you're just starting the night before the test or something like that. All right, so, oops, went up, okay, but did you find this video useful? All right, please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? It's simple. YouTube does not let me have any ad revenue, doesn't give me any share of it, unless I have 1,000 subscribers and 4,000 hours of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time. I don't have anywhere near 1,000 subscribers. And for those reasons, you are not only welcome, but encouraged to share links to this video, put it in your playlist, whatever you want. I'm always happy to read and respond to constructive criticism or suggestions for new videos. I reserve the right to delete comments from and block those who specialize in destructive criticism. You know, trolls or things that are off topics. You know, spammers, disturbed people, people who just decide that they have something that they just really, really need to say in my video comments that, no, they don't. Anyway, contact me. My cell phone number is 415-623-4251. You can email me at john@johnlinneball.com. Mail me at 1859 Powell Street, number 109, San Francisco, California, 94133. And if you have a copyright issue, I know we skipped it before, but I wanted to cover it here, is you think that I've used something of yours that's copyrighted, please contact me. I would be glad to discuss it with you. I'm pretty sure anything I'm using is completely fair use, but anyway. In any event, thanks for watching. If you need more contact information, there's more coming up. Contact me on Facebook. You can get me at Facebook at facebook.com/Linneball Tutoring. Instagram.com/John Linneball Tutoring. Phone 415-986-7355. Email john@johnlinneball.com. Website is johnlinneball.com or johnlinneballtutoring.com. And testpreparation.locals.com is my locals page where you can support me, and I have a lot of the same content right now, and well, actually all the same content as my YouTube channel, but I will be putting up exclusive subscribers only content very shortly. All right.